everyone. Welcome to today's live broadcast, Quantification and Identification of Microplastics in Air using Pyrolysis-GC. I'm Shannon Stoltz, Senior Editor for LC-GC, and I'll be your moderator for today's event. We are pleased to bring you this webcast presented by LC-GC and sponsored by Quantum Analytics. Quantum Analytics is a value-added distributor of analytical instrumentation in the US and Canada. It offers financing on new and refurbished instruments, including gas chromatography, liquid chromatography, mass spectrometry, and related accessories. It specializes in multi-vendor solutions, including Pyrolysis-GC and thermal desorption GC. The company's services are designed to support a new lab startup or keep an established lab moving forward. Quantum Analytics is proud to be an Agilent channel partner. I would now like to introduce today's speakers. We are pleased to be joined today by Regine Belganet and Athena Nguyen. Regine is the Technical Director at Frontier Laboratories Americas. As a former user of Frontier products with more than 10 years of experience in analytical instrumentation, Regine is passionate about creating awareness surrounding Frontier technology and providing technical support to users. Athena is a technical support specialist at Frontier Laboratories Americas. She graduated from the University of Houston with a Bachelor of Science in Chemistry. In her current role, Athena splits her time between working in the lab and providing technical product support while continuing to advance her polymer characterization capabilities. Thank you both so much for joining us today. Please get us started.
Thank you very much, Shannon, for the introduction. So before we start today, I also would like to thank our channel partner, Quantum Analytics, for sponsoring today's event. And we've been working with Quantum Analytics for more than a decade now. They are our authorized distributor for our products in the US and Canada on Agilent systems. So here is our agenda for today. We are actually dividing our webinar into two parts. In part one, we will learn about the microfurnace Pyrolysis-GC system configuration and also its workflow for microplastic analysis. We then look at the main components of the configuration to better understand how the microfurnace pyrolyzer can be used for quantification and qualification of microplastics. The main components we will focus today are the actual microfurnace pyrolyzer, the FSearch software that is used for analyzing the microplastics, the calibration standard kit, and the column kit that are designed specifically for microplastic, and also our spitless sampler that enables you to perform a spitless analysis. I also like to mention that although microfurnace Pyrolysis-GC has a very broad application in polymers and additives, in our today's event, we are mainly focusing on the microplastic analysis. So we'll briefly go over the capabilities of the microfurnace, but we also have many other available resources that goes into much detail about the technology and its other application that you can easily access. Then after part one, which is the background and theory, then in part two, we will present an application note for quantification and identification of microplastic polymers in air that was used microfurnace Pyrolysis-GC. So here you can see the comprehensive system configuration using microfurnace Pyrolysis-GC for microplastics analysis. Some of the components are application dependent. For example, the microjet cryo trap is an accessory that is used if you want to analyze light additives or if you use the spitless pyrolysis. The microfurnace pyrolyzer directly connects to your GC injection port, so your pyrolysis will be a continuous pyrolysis where all the pyrolysates as they are generated are deposited directly and continuously on your GC column. You can also use the auto-shot sampler that is on top of the microfurnace in this figure, and that can automate up to 48 analysis for you. And then specific to microplastic analysis, we also developed a column kit, a packed GC glass liner, microplastic calibration standards kit, and also FSearch MP software. The multifunctional spitless sampler and the microjet cryotrap, as I mentioned, are other accessories that you can use based on your application of interest. So the workflow is very simple and very easy using your microfurnace Pyrolysis-GC. The step one is sampling. You simply place a few micrograms of your sample or the calibration standard sample into an inert sample cup. Step two is to place the sample cup into the AutoShot sampler and start your analysis. And then step three is the data interpretation using your Upsurge MP software. And we will talk more in detail about each step during the application note part of this webinar. So as I mentioned, the low-mass ceramic microfurnace pyrolyzer directly connects to your GC injection port. So there won't be any transfer line and no dead volume. Sample introduction is nearly instantaneous. The sample is placed in an inert sample cup and is held at near ambient temperature in helium with no exposure to heat before the analysis. The microfurnace is then preheated to the desired temperature, and that temperature is whatever temperature you set your furnace into. And that temperature is actually precisely measured with a thermocouple sensor. The sample cup then drops into the quartz pyrolysis tube where the sample is rapidly and reproducibly pyrolyzed. The pyrolysates are then directly swept onto your GC column for separation and detection by MS. By directly depositing all your pyrolysates on column in a single step for a continuous mode analysis, low and high molecular weights as well as polar compounds can be detected and analyzed. The microfurnace also guarantees reproducibility and accuracy of the temperature within plus or minus 0.1 degrees Celsius. It is compatible with your major GC manufacturers, and all surfaces are quartz or temperature stable deactivated. The last slide I want to talk about microfurnace is that this furnace is a multifunctional furnace, which means that you can perform multiple analytical techniques using the microfurnace, such as evolved gas analysis. You can perform thermal desorption, hard cutting, all in addition to your flash pyrolysis. So the microfurnace can perform both thermal and separation analysis with isothermal or temperature programmed setting. Evolved gas analysis, known as EGA, is the thermal analysis of your sample that shows you the thermal behavior of your sample toward the temperature by temperature program heating of the sample and directly detecting the evolved gases with MS. The other modes, as you can see here, such as the flash pyrolysis, which is also called the single shot, or the double shot, or the hard cutting mode of operation, they're all the separation analysis, where you would use the separation column to chemically characterize the organic composition of your samples. And in our today's application notes, we are focusing on the single shot or the flash pyrolysis mode of operation, which is an instantaneous and continuous pyrolysis of your sample using the separation column. The other modes can also be used with the same system based on your application of interest. So now let's talk about the microplastic calibration standard kit. The Microplastics Calibration Standards Kit allows you to easily create your calibration curves for the quantification of microplastics. 2 microplastic calibration standards with different diluents, SiO2 or CaCO3, are available in your kit. Both of them contain a few micrograms each of commonly used 12 polymers, which are homogeneously dispersed with a solid diluent for easy weighting on a semi-microbalance. And since the quantification target is microgram order or low in majority of cases, ultra microbalance is needed to measure sample weight in a microgram range or less. However, For those who only have a semi-microbalance in your lab, we also developed a sampling method to measure microgram order samples. So you just add SiO2 or CaCO3 diluents into your environmental sample. For example, you add CaCO3 diluents at 100 times larger than the environmental sample, and then dilute the environmental sample. So if you measure 1 milligram of the diluted environmental sample, it means that you measure 0.01 milligram of the environmental sample. This sample prep really enables you to measure such a small amount of the sample using a semi-microbalance. Now, for sample preparation, you need to prepare your calibration standard and your environmental samples. We provide the microplastic calibration standards of 12 polymer mixture to you. You just need to measure the weight of your calibration standards to create a calibration curve. Now, for your environmental samples, you might need to do some sample pretreatment to remove proteins, organics, and inorganic. Then, if needed, you can also use our cryogenic mill device to homogenize the sample. Then pyrolyze about 0.1 milligram of your unknown sample. This table that you can see here guides you on how to select the appropriate microplastic calibration standard. You can select the type of microplastic calibration standard based on your target polymers. So you could either select the MP's SiO2 or the CaCO3s or the MPCS SiO2 with the TMAH. Now, if you don't have any target at first, you can start with your MPCACO3 standard that can target pretty much all of the 12 polymers, but with very low sensitivity to PET. So in that case, to target PET and or PC, you can use MP's SiO2 with TMAH, which is a tetramethylammonium hydroxide, as an alkali reagent used for reactive pyrolysis to improve the sensitivity. Also, as you can see here with MP's SiO2, PU cannot be targeted because its quantification peaks react with PET and nylon 6,6. So in this case, if you are targeting PU, you would need to use the MPCACO3 standard sample. So now let's talk about the FSurge MP software. The latest version is FSurge MP's 2.1. FSurge MPs is an analytical software used with the data obtained by Pyrolysis-GC for microplastics analysis. It allows you to easily and accurately identify and quantify unknown microplastics in the environment. It consists of a patented search program with mass spectral libraries of the pyrolysates. The software also automatically creates calibration curves for the register polymers based on the analytical results from the reference polymer mixture. There is a library for 12 commonly used polymers as shown here, and you can also create your own libraries for any additional polymers. There are only 4 straightforward steps for operational process by FSurge MP software. Step 1 is to create a plot of retention index. And the retention index is created based on the pyrolysates of microplastics calibration standards. Step 2 is creating a calibration file that is based on the pyrograms of microplastic calibration standards. And step 3 is searching results of microplastics that is both quantitative and qualitative. And then the last step is to review and confirm the searching results. Now, let's go over each step in more detail. And in part 2, when we are showing the application note, you can also see how each step is performed in more detail. So here you can see the step 1 in the F-Search MP software, in which the retention index is automatically adjusted based on the pyrolysates of polystyrene using the microplastic calibration standards. You can simply perform this step by clicking on the RI-Cal from STD sample in the software, as you can see here, and that is going to do the retention index calculation from the standard sample for you. Then F-Search MPs create the calibration curves for each 12 polymers with extracted ion chromatogram peak of preset quantitative ions. And just in a few seconds, you can then see the quantitative and qualitative results, as well as the MS spectrum and peak shape for each polymer. And here is a closer view of the search result. You will get the match quality percentage for each polymer, all the polymers that are here, the quantitative result in micrograms, the relative amount in percentage, peak area, and also LOQ. Also, there will be a bar graph of the relative amount in percentage for each polymer at the bottom of your search result. And, as you've experienced with every interpretation library and software, at the end, the results needs to be reviewed and confirmed. As your last step, you want to check for the peak shape, the retention time, mass spectrum, and then the peak integration areas of each polymer listed in your search result. Now let's talk about the UAMP column kit that was specifically designed for microplastic analysis. So the UAMP column kit consists of a separation column, a pre-column with a medium polarity, and a UA connector. This product really improves the accuracy of quantitative and qualitative analysis of plastic mixture using your F-Search MP software. Also, it reduces the contamination of the separation column, so reducing the replacement frequency of your column. And here we are showing an example on how the UA pre-column improves separation and identification of C8 pyrolysate that is generated from PE from cyclophenodiene that is a pyrolysate of nylon 6,6. So with the UA pre-column, the co-eloding pyrolysates of P and nylon 6,6 can be separated and identified. Whereas without the UA pre-column, as you can see on the first chromatogram, there will be one peak that is the co-eloding or mixture of C8 and the cyclophenodiene. Same thing with the packed GC glass insert that we developed specifically for microplastic analysis. And it improves the peak shape of the pyrolysates generated from the microplastics. In addition to better peak shape, the packed GC glass insert also improves the accuracy of qualitative and quantitative analysis of a specific plastic in polymer mixture samples. So here I'm showing an example of a PE sample that we did flash pyrolysis on, 600C. The top pyrogram is the one obtained using a regular GC liner or GC insert without any packing. And you can see that from C20 to C30, the peaks are very broad and they have a lower peak height. Whereas at the bottom pyrogram is the one that we obtained using the packed GC glass insert. And as you can see, the peaks are sharper and peak heights are improved. So the last accessory we are going to talk about before showing the application note is the multifunctional splitless sampler that is very application dependent, but I thought to talk about it a little bit here in one slide since Atina used this accessory for her application note. So the multifunctional spitless sampler, it's an accessory that add on to your system of your Pyrolysis-GC system and allows you to perform a new spitless pyrolysis, backflush, solvent cut, and also improve your peak separation. So as you might know, in a normal spitless pyrolysis or in a traditional spitless pyrolysis, the low helium flow rate can cause secondary reactions that are greatly change the pyrogram profile. Now, with the new spitless pyrolysis, using the multifunctional spitless sampler, higher helium flow rate reduces the secondary reaction and also increases sensitivity by about 50 times compared to the split of 1 to 50. Also, higher boiling compounds in the pyrolysates tend to remain in the separation column that can result in ghost peaks. And the multifunctional spitless sampler prevents contamination of the separation column by backflushing the high boiling compounds remained in the pre-column, thus significantly shortening the analysis time as well. And you can also perform a solvent cut to prevent the solvent and to protect your system. So with that, this is the end of part 1. We hope that you got a good understanding and feel for the background and theory of the microfurnace Pyrolysis-GC. And now I would like to give the mic to Atina so she can present her work that she recently did for microplastic analysis in air.